Okay, thank you. Good afternoon, my name is Artur Milewski and this is my friend Jakub Kuryło. We are from Białystok University of Technology in Poland. Today we would like to present to you a control system, telemetry and navigation of Mars rover analog. Mars rover analog RED, it's from Reconnaissance, Exploration and Discovery, was constructed to participate in University Rover Challenge 2016. This competition of Mars rover occurs yearly in the United States on the Utah Desert, which is one of the most similar places on Earth to the Mars. During this challenge, terrain and manipulation abilities of the robot has been tested. RED is a six-wheeled robot based on a differential control steering with implemented algorithm. Its onboard computer was designed in such a way that even in an unlikely event of its partial failure, robot will still be able to perform basic operations. Onboard computer is managed by the real-time operating system FreeRTOS for appropriate RED performance. Numerous sensors enable an analysis of the current robot state, determine its location, and can even perform a preliminary examination of collected source sample. All data is presented in suitable form by the command center application. To increase the operational abilities of the robot, autonomous robot tracking system was designed. All of this create a fully functional system ready to explore new and hard to reach areas.
This is our main module of our computer. This is one of three PCB boards was designed for driving engines control, robotic arm operations, and exchange information between Mars rover and base station. This module based on STM32 microcontroller. In this card work under FreeRTOS system. All navigation systems were designed for University Rover Challenge competition that takes place on Earth. GPS receiver working together with IMU to provide the most accurate positioning in local as well as global coordinate system. This is critical for the proper functioning of the common filter and other steering subsystems. We decided to use a small GPS module based on MT3339 chip. This GPS module can work with integrated ceramic antenna and with external high-gain antenna connected to the board by SMA connector. Data are transmitted to microcontroller up to 10 times a second by a serial interface. IMU odometry system consists of 9 degrees of freedom IMU, accelerometer, gyroscope, magnetometer and pressure sensor, and information from incremental encoders. IMU consists of sensors manufactured by STM Microelectronics company in MEMS technology. All sensory data combined create complete odometry model of our analog Mars rover in a computer system.
The software on the onboard computer uses a real-time system FreeRTOS. The program performs 7 tasks presented in this table. 6 of them are created at the start of the program. 1 is created in the course of the program if necessary. Using real-time system in the project made it possible to achieve greater software reliability and reduce time needed to needed time for implementation of some functions due to parallel task execution. So first one is receiving data from the radio receiver and analysis of the correctness of the data frame. Second one is receiving data from the GPS module and processing of data using a low-pass filter. Following, reading data from the image sensor. Next, reading data from the sensor responsible for measurements during this test soil samples. Fifth, send back feedback data and the data for the slave units. Sixth, reading data from the slave microcontrollers. And last one, autonomous driving robot. The task is created after receiving by the robot's specific data frame. Autonomous robot tracking system was built to increase the robot's operation area. You can see this on this picture. And the system allows to combine the advantages of directional antenna extending signal vision range and omnidirectional antenna by maintaining good coverage in each direction. This allows a maximum possible scope in every way. To determine the direction and location of the antenna, system uses a magnetometer and GPS modules in order to direct it to the rover red. Necessary information is derived from the GPS of the robot. After data analyzing, antenna is able to direct itself towards the robot. And you can see how it works on this schema. So we have two angles. First one alpha we get from magnetometer, and we have angle beta, and it's calculated based on the rover's and antenna's GPS position. We have also here a laptop from which it can be steering, and we have feedback information. It communicates via RS232. The accuracy of rotation depends mainly on the accuracy of antenna location and rovers. One of negligible factor is magnetometer interference. In order to reduce noise, magnetometer module is placed away from the engine and to reduce steel elements in the design. An important element is also the engine with high torque that allows a slow rotation. For safety reasons, there is possibility to relinquish manual control of the system. The inclusion of autonomous operation is initiated when the vehicle is at the right distance from the antenna. From practice, it's about 100 meters. Otherwise, inaccurate determination of both GPS rovers and mast could cause antenna misdirection, as the feedback mast refers to the base the direction. With autonomous robot tracking system, operator is able to receiving images from each camera from about 1 kilometer distance. This range depends on the type of terrain in which robot is located.
For steering our Mars rover analog and reading data from it, we use a command center application. This software was designed and created in C# language in Microsoft Visual Studio developer software. Command center application has many tabs consisting of many options improving each task's performance. The application's main task is to create data frame, commands used for the Mars rover control and reception, collection and data presentation of information about rover state. The first tab named General is fitted out with GPS scroll map, camera screen, artificial horizon and compass. All of this information helps the Mars rover operator for drive control. The second tab has numerous functionalities regarding on laboratory examination. On this tab, one can glance at all unavailable information about cached sample like a temperature, relative humidity, pH, etc. We have a variety of information about area around cached place too, including latitude, longitude, means above mean sea level, wind speed, wind direction, and ambient temperature. Traversing tab is the next tab. Is used for astronaut assistance and traversing task. At the center of tab, a big GPS scroll map can be seen. It has marked position of looked of astronauts or gates, a place to catch tools, obviously our Mars rover. On the left-hand side of this tab are listed options for addition and removal astronauts data. The third option is marked with the Go to Astronaut button. This option initiates the rover self-driving mode. In results, in our rover autonomous voyage to the indicated location, an astronaut, for example. On the right hand side of this tab, we can see a few options about containers that we used in astronaut assistance task to catch tools and delivering them to designated place.
Okay, to sum up, presented solution allowed us to achieve 7th place in the University Rover Challenge 2016 and 5th place at European Rover Challenge 2016. Autonomous robot tracking system increased vision range. Command center application with specialized task tabs made operation job simpler. Specially designed onboard computer allowed to operate peripherals and protects robot from many electronic faults. Real-time system creators significantly increase the functioning speed of the robot so that it's ready to work almost immediately after turning on. Thank you for your attention.
Does anybody have any questions?
Yes, sorry. The free rotor system, the software that you use, partially, I don't know how you say it. What competitor packages did you use to use that one? Was it just that it was a free system or what?
Just a second.
Again,
Let me translate the question. Użyliście FreeRTOS-a, tak? Chodzi o to, czy z jakich pakietów korzystaliście przy budowaniu tego oprogramowania oraz czy rozważaliście inne rozwiązania konkurencji?
We do not use any other solutions. We don't try it because we have not many time. Yeah, it's only partial job. We need to prepare our robot for other tasks, so we maybe have for this 1 month only.
Any other questions? All right, thank you very much.